Hello viewers. So today we'll be discussing about Johnson-Trotter algorithm. So Johnson-Trotter algorithm is a part of minimal change algorithm. It is one of the classification of minimal change algorithm. So this algorithm is used for generating all permutations by swapping one element at a time. So the main concept behind this algorithm is that you have to generate permutations in such a way that you have to swap one element at a time. Remember that you have to swap one element at a time. And coming to the application, so the real-time applications where this algorithm is applied is cryptography, robotics, graph theory, and many more. But the main important concepts where this can be applied is cryptography, where in cryptography it is used for key generation and encryption. So the purpose of Johnson-Trotter algorithm used in cryptography is in certain concepts where it is used for generating the keys for encryption and decryption purpose. And next, moving on to robotics, it is used for assembly and navigation of robots. That is planning the movements of the robots, how to move and all. And next, moving on to the graph theory, it is used for routing and scheduling. So routing and scheduling is nothing but, for example, identifying the Hamiltonian paths, Hamiltonian cycles, etc. So there are many more applications where this algorithm is applied, but few important concepts are cryptography, robotics, and graph theory. So these are the applications of Johnson-Trotter algorithm. Now moving on to the algorithm. Before starting with an example, let us first discuss about the algorithm part. Then we can move on to the example. So first is initialization. In the initialization, what happens is that you have to start with the initial permutations. And that is for a given set of integers. So you'll be given with an input of set of integers 1 to n, which are already arranged in ascending order. So that is what the initialization is. So you have to start generating the permutations. For every algorithm, there is a concept, or the first step is nothing but primary step is nothing but initialization. So here in Johnson-Trotter algorithm, the initialization starts with the integer set of integers given to you. That could be of input 1, 2, 3, 4, 1, 2, 3, or whatever it is. So that is 1 to n as described, which are already arranged in ascending order. So this is what first initialization is. You have to start generating the permutations for the initial step 1 to n, which are already arranged in ascending order. Now moving on to the second step, finding mobile elements. So this is the key concept of Johnson-Trotter algorithm. So where you have to identify this mobile element. So you have to identify mobile element. I'll tell you what mobile element is. Mobile element is something which is greater than the adjacent element. For example, given 1, 2, 3. So you have to identify the mobile elements in this. So you have to compare each and every element. Compare and identify if it is greater than, if there is any adjacent greater element. For example, for 1, the adjacent greater element is 2. For 2, the adjacent greater element is 3. Like that, you have to identify how many mobile elements are there. So mobile element is nothing but it is the element which is greater than the adjacent element. So that is what mobile element is. So that is the key concept. Now moving on to next part, after finding the mobile elements, you have to look into finding largest mobile element. So for a given set of input, you have to first generate how many mobile elements are there. So once the mobile elements are generated, you have to identify the largest mobile element in that, so which is denoted by k. So first part is you have to identify what are the adjacent greater elements, which are nothing but mobile elements. How many of them are generated? For example, in this given set 1, 2, 3, for 1 the adjacent element is 2. So 2 is greater, so you have to write 2. And next for the 2 the adjacent element is 3, 3 is also greater. So these are the two mobile elements we got. Now from that you have to identify largest mobile element. So from 2 and 3, 3 is the largest mobile element, which is denoted by k. So this is the third step. Now next fourth step is that you have to swap elements k with adjacent element to which arrow points. So this we'll be discussing in the example. So right now just remember the first step is that the initialization, where the permutations generation will be starting from the given input as given as 1 to n, which are already arranged in ascending order. Next second is finding mobile element. So what mobile element is? while comparing the number of elements if there is any greatest element, so that is called as adjacent element, that is one which is greater than its adjacent. And next third one is finding the largest mobile element. So from these mobile elements generated for the given input, you have to identify the largest mobile element. Once the largest mobile element is generated, you have to start swapping the elements that are present in the given input. And next step is, next is fifth step is reverse direction. So reverse direction of arrows for all the elements greater than k. If for example there is a greater element than this, for example in this given input I have got the greatest element as 3. For suppose there is any largest element than 3, so for example consider 1 2 3 4 or whatever it is. So for example if I have taken 3 is the largest mobile element, if there is already any largest element greater than this mobile element k, so if there is any element greater than k, then you have to reverse the direction of that element. So we'll be looking that in the example. So the fifth step is that reverse direction of arrows for all elements greater than k. Next, sixth one is generate permutation. So if for the given input 1 2 3 or 1 2 3 4, you have to generate all the permutations until there are no more mobile elements left. So we have to repeat the steps 2 to 6. That is from identifying mobile element, finding largest mobile element, swapping elements, next reverse direction, next generating permutations. You have to generate all the permutations until there is no mobile element left. So once the no mobile element is left, there ends the number of permutations generated. So that is what the Johnson Trotter algorithm is. So Johnson Trotter algorithm is nothing but you have to generate all the permutations by swapping one element at a time. So we have discussed the applications, we have discussed the algorithm, initialization, finding mobile elements, finding largest mobile element, swapping elements, and next you have to reverse the direction. Next, generate the permutations. So you have to generate permutations until no mobile element is left. So this is what Johnson Trotter algorithm is.